Bienvenidos, Ushamdi, and welcome CTS-131 Section 875 students for the Spring 2018 semester at Anne Arundel Community College. This is the Cisco Networking Academy's Routing and Switching Essentials version 6 course, or the AACC Networking 2 course, and this morning's Packet Tracer tutorial and solution set is going to be on Packet Tracer Activity 8.3.1.2, where we're going to be taking a look at the Dhcp Chapter 8 Skills Integration Challenge. So let's go ahead and dive in and take a look at our topology. All right, so I'm going to move the drawing tool just a little bit there. So here's the topology that we're dealing with. We've got our addressing table over here on the right-hand side. You can see we've got some sub-interface work. And let's see what is going to be required. So we're going to have to create some VLANs, some trunks, a DHCP server, DHCP relay agents, and we're going to configure a router as a DHCP client. So let's fire it up here with our requirements. We're going to create VLANs on switch 2 and assign VLANs to appropriate ports. And the names are case sensitive. And you can see here we've got all of our VLAN names and numbers here. So let's fire up switch 2. And let's go ahead and come out to the CLI. Let's give ourselves a little more room with which to work. All right, so we're going to get into privilege exec from global config with the enable command, and then we're going to go from privilege exec, we're going to go from user exec to privilege exec with the enable command. We're going to go from privilege exec to global config with the configure terminal command. All right, so create VLANs on switch 2. So how do we do that? Well, we simply say VLAN 10, and then the name is going to be sales, and then we say VLAN 20, and the name of that VLAN is going to be production, and then we say VLAN 30, and the name is going to be marketing, and then VLAN 40, and the name of VLAN 40 is going to be HR, so name HR, and you can see we picked up a few points there along the way. It looks like one per VLAN. All right, and assign the appropriate ports. Well, here's where we're going to move into global config, and we're going to be using that interface range command. So we're going to say interface range fast Ethernet 05 to 9, and that's going to include our sales VLAN. So I'm actually going to do a switch port mode access and then switch port access VLAN, VLAN 10. And that assigns VLAN 10 to that group of ports. I'm also going to say no shut. Now they may have us shut these down later, and that's okay, but we're going to make sure that everything that needs to be up is up. And then I'm going to say interface range fast Ethernet 010 to 14. We're going to say switch port mode access, and then we're going to say switch port access VLAN 20 for production. And then I'm going to throw a no shut in there. And then let's come back and say interface range fast Ethernet 0/15 to 19 and switch port mode access, and then switch port access VLAN 30. And then last but not least, interface range fast Ethernet 0/20 to 24 and switch port mode access, switch port access VLAN 40 for the HR VLAN. I'm going to type in, and we're going to save our information here with a write mem. You could type copy running config startup config, and that looks like it should do it for the VLAN piece. So on switch number 2, we're going to configure ports for trunking. And you can see that the ports that we would be using to do trunking are going to be fast Ethernet 01 to 04. So let's get into global config again. I'm going to say interface range fast Ethernet 01 to 4. And how do we make a trunk port? Well, we say switch port mode trunk, or just switch port MT, right? I can abbreviate all the way down to switch port, I could actually say SW, I think, and then MT. And so that's going to allow me to turn those into trunk ports. I can also say switch port no negotiate, right? Because we're going to turn off the dynamic trunking protocol on those ports. On the host ports that we just configured, when I said switch port mode access, that turned off the dynamic trunking protocol there. On a trunk port, to turn off the dynamic trunking protocol and to hard code it so that it is hard coded as a trunk port, you simply say switch port no negotiate. Now, if I say do show interface trunk, this is going to show me, and let me go back to the beginning here. This is going to show me the ports that are configured as trunk ports, shows me the native VLAN that they're using, shows me the encapsulation that's being used, 802.1q, and this is the default now on all new Cisco equipment. There is no other choice for ISL, which is a legacy Cisco proprietary technology. And you see the trunk mode is on here in the second column. Now you may be wondering, well, why do we need 4 trunk links? Well, we've got redundant connectivity here. We want to make sure that no matter what happens, if we lose fast Ethernet 01 or maybe 02, or what if we lost fast Ethernet 01, 02, and 03, we would still have fast Ethernet 04. Now at this point in the course, we haven't talked about, and I don't believe that we talk about Ether channel or creating link aggregation groups until routing and switching essentials. So I'm going to leave that off to the side for right now, but that would be another approach that we could use here, but this is just generic trunk ports. So I think we're good on the trunking, and I don't need to say no shut because they're already all up, but even if I said no shut, that doesn't change anything. All right, configure all non-trunk ports on switch 2 as access ports, and we've actually done that. We already did that with that switch port mode access. All right, configure router 1 to route between the VLANs. So here's router 1, and you can see we're connected to switch 1. Now, this should be sort of old hat in terms of material. We should be very comfortable with Inter-VLAN routing, specifically configuring the router on a stick. So let's pull router 1 up here, and we'll bring it down into this area here, and we'll get onto the CLI, and you can see we're at user exec mode. Now, if I go ahead and say EN and enable to move into privilege exec and say show IP, show IP interface brief, they kindly labeled the interfaces here between the router and the switch. This may not always be the case, but it is the case here, so we are definitely going to capitalize on that and take advantage of that. So I'm going to get into global config. I'm going to go into interface gigabit Ethernet 00. Now, I could wait to say no shut here until the very end. However, I want to bring it up and allow spanning tree on the switch side to do its thing. So here's how we're going to transition to the configuration portion. I'm in the main parent interface. If I look at the addressing table here, I can see I've got the gig 00.10.20.30.40, and it gives me all of the information I need. So very, very easy task right here in front of us. So I'm going to go into interface gigabit Ethernet 00.10. Now, what happens if I say, if I'm rushing through here and I say IP address 172.31.10.1, 255.224? What happens when I hit enter here? Is that going to put the IP address on that sub interface? That same sub interface that is 100% dependent on being able to differentiate the traffic that shows up on the parent interface based on VLAN. And yeah, you could probably tell by the intonation in my voice that this was not going to happen and that we were not going to have a happy result here, and we didn't. So we get an error message, right? But you can look at it as a fortuitous failure. You say, oh, right, that's right. I've got to go ahead and say incap.1q, and we're going to use 10. Now, remember, the sub-interface number that we use here, when I say interface gig 00.10, does not have to match the VLAN number. But again, you would be crazy not to match everything up because it's going to make troubleshooting a lot easier down the road. Now I can come back and put the IP address on here. And if I was to say do show IP interface brief, you're going to see that the interface, since the parent interface has been brought up, the child interfaces that we create, or the sub interfaces we create, are also going to be up. So let's go into interface gigabit Ethernet 00.20. We're going to say incap.1q 20. IP address is going to be, in fact, I'm just going to do this because they're so close. And of course, they're going to make me change the subnet mask. And I'm just going to have to change the third octet. And that's all that's different between what we're doing here. Interface gigabit Ethernet 00.30. And it's going to be incap.1q 30. And then oops, sorry. incap.1q, and I lost it there. Incap.1q 30, and then we're going to bring the IP address statement back up. The subnet mask changes to a /25, and the third octet changes to a 30. And then we're going to go interface gigabit Ethernet 00.40, and incap.1q 40. And the IP is going to be very similar, but it is a /26, a 192, and the third octet is a 40. Now, there we go. Okay, so that has been taken care of. So we're at 29 out of 100 points. Let's do a do show IP interface brief. And everything looks good here, but let's not forget to come over to the switch. Oops, sorry, I didn't want to do that. Apologies. Come over to the switch side of the equation so that we can take a look here at the CLI tab is locked. Okay. And there's no way for me, okay, so it's got to be that this is pre-configured, that it's locked down but pre-configured. Now, let me ask you, how can I check to see that this gig01 port on the switch is in fact configured as a trunk port, and I have reachability to router 1's sub-interfaces from each of the VLANs? How can I do that? Yeah, I could come down to these different PCs here, and I'm looking up here, and so that I don't blow up the scoring engine, I was going to go ahead and put statics, but remember, we're going to be doing DHCP. That is going to be the ultimate check. Now, gigabit Ethernet 01 here on the router, it says it's going to act as a DHCP server for the VLANs attached to switch 2. But when we look at the interface here, gig01, it needs to be configured to get its IP address via DHCP. And so how do we do that? Let's take a look at gig01 on router 1. So I need to keep coming down here. And you can see it says description, connection to ISP, no IP address, and the interface is shut down. So how do we tell the router that, hey, you're going to be a DHCP client? In other words, you're going to need to get your IP address from the ISP. And I like this because this is a real world example. If you were to take a Cisco router and connect up to Verizon directly, right, you would need to get a DHCP address, and so this is how we would configure that. We would go into interface gigabit Ethernet 01. We're going to say no shut because the interface is shut down. You can see it's up now. We've got our spanning tree challenges, and so I'm going to let that, I'm not going to do the fast forward thing. I'm going to let that sort itself out here, and let's come over and take a quick look. So configure all non-trunk ports as access ports. We did that. Configure router 1 as the Inter-VLAN router. We did that. Now we're going to set it up to be the DHCP server. We're going to create a pool. We've got our pool names, and we've got our networks that we're going to be using. We know the default router because that's the address. We need to get it to router 1 as the default router, so we know how to do that, and it gives us some additional information. And pay very close attention to that right there. So we've got an IP DHCP excluded component here. We're going to be excluding the first 10 addresses from each of the pools. Verify that each PC has an address assigned. Okay, so then we're going to check on the PCs. So while I read through that and we're straight on what we're going to do immediately after this, we're now up here. So let's go ahead and say do show IP interface brief. Are we going to have an IP address? Is me saying no shut enough to give the router an IP address? And the answer is no. And we should know that, right? Because what do I need to say? I need to say IP address. And if you do a question mark here, take a look at the options we got, or that we have, right? DHCP. So I just simply say IP address, DHCP, and we should, yeah, good, okay, great. We should see a DHCP syslog message, and we did, address assignment, right? Severity level 6. Okay, so informational. And then we get the rest of the information, and it shows me the address and the mask. So now when I say do show IP address, do show IP interface brief, we see that that is the address that we have been assigned. And we also see that we're at 36 out of 100, and the method of assignment is DHCP, where I manually configured these 4 here, Now it's DHCP. Okay, so that's been taken care of. So now let's get on to router 1, which we're already on here, and let's get into global config. So here is what I'm going to do, and I like to do this first, is the IP DHCP excluded, because you do that at the global config level. So if I was to say IP DHCP excluded address, I'm doing it at global config. I'm not doing it in the DHCP pool configuration. So I want to get this out of the way, because I know that for each of these 4 networks, these 4 VLANs, these 4 subnets, right? Remember, a VLAN is a subnet, is a broadcast domain. I'm going to exclude the first 10 IPs. And so actually, this may be a little, actually, no, it's not going to be tricky at all. Okay, I was looking at the subnet masks to make sure that they weren't doing variable length subnet masking in the same range. And so this actually will be pretty straightforward. So we're going to say IP DHCP excluded address 172.31.10. Now, remember, I want to exclude from .1 up to 172.31.10.10 because the requirement is prevent the first 10 IP addresses from each pool from being distributed to end devices. And again, the important reason for doing the excluded, and this is another, actually, this just dawned on me. I probably should have said this right up front. The other reason I like doing this is not because it's outside of the pool configuration, but because if I go in and do the pool configuration before I do the exclude statement, what could happen? Yeah, if those PCs are out there trying to get addresses via DHCP, yeah, they're going to gobble those addresses up before I even get to the excluded, right? And it's too late at that point. So if I enabled DHCP, configured the pool, and the PCs do get addresses right out of the gate, when I put the exclude statement on there, DHCP on the PC is not smart enough to say, oh, hey, so I see that the router, who's the DHCP server, yeah, I see that he didn't want me to take this address, so I'm going to go ahead and drop this address and get a new address. That does not happen, right? So I should say the most important reason for doing the exclude statements first, and probably why they have this statement last out of all the things to do, right, is sort of being a little sneaky on you there, is that it's going to prevent the PCs, if they were configured to pull DHCP addresses and they pull it before I get this statement in there, we've got a problem. So we're going to do that. I'm going to watch the meter move from 36. We should see, yeah, so that's a 3-pointer. So these are going to be 12 easy points here because all I need to do now is come in and change the third octet. That should be another 3 points, push us to 45, or actually it already did, push us to 42 actually. And then 30, so this should push us to 45. And it did, and we're going to come in and do 40. Right, so very, very low-hanging fruit here. And again, yeah, I like to do it first because to get it out of the way, but technically the most important reason to get that done is for what we're getting ready to do right now, to prevent the hosts from grabbing addresses before I put those exclude statements in. So we're going to create a DHCP pool for each VLAN. Names are case sensitive. And I'm squinting here looking at the pool name. So we're going to say IP DHCP pool, and we need to be careful here, VLAN _10. Now, one of the great things about Packet Tracer is it gets rid of a whole lot of options that you would normally see if you were doing this on a real Cisco router. So we look at this and I see, okay, default router. I can kind of walk through this in order. So my default router, again, for VLAN 10 is going to be what? Excuse me. Yeah, it's going to be the interface, the sub interface on the router on a stick configuration, and VLAN 10 is 172.31.10.1. So it's that easy. DNS server. Yep, they want us to configure a DNS server. So we're going to say DNS server, and it's going to be 209.165.201.14. And we get that on there. Okay, and hold on one second, and DNS server, we don't want to exit, and then the network. So for what network are we doing this for? And again, pretty convenient, right? They're setting us up here with what we need. So 172.31.10.0, and what do I have to put? The network mask. Well, that was already provided to me in the addressing table. So again, I like how they did this here because the focus is on the DHCP component of this activity, right? It's not about me having to stop and work out 4 different subnet masks and subnet mask lengths and what the wildcard masks might be. So it's all about DHCP here. So that's going to be the network statement. There are no options that we're setting, right? So if I look at this again, I assign the appropriate addresses to each pool, the network statement. Configured DHCP to provide the default gateway, did the DNS, and we've already done the exclude. So at this point, I should be able to come over here and VLAN 10 PC1, let's do a quick test. Let's come to our desktop, come to the configuration, and you can see they had static clicked here, right? So if you had forgotten to do the exclude statement, you would have been okay in VLAN 10. And my guess is all 4 VLANs are going to look just like this. But had that been the default selection, we would have been in trouble. And did it exclude the first 10? Absolutely. Now I can check in VLAN 10 to see, hey, do I have connectivity? And what do you think the answer is going to be? If I got the DHCP address, then it's a pretty good possibility that I'm going to be able to ping 172.31.10.1, right? And that works fantastic. Okay, what does it say? R1 is a DHCP client. I'm looking down further, so testing all the way out. Okay, so can I ping www.cisco.pka? And let's see if I've got reachability. Chances are we've got a little DNS resolution going on. We've got an ARP that's probably going to be taking place here. And no dice yet. There may be something else we're going to have to do here on, and I'm just looking forward a little bit. Yeah, there may be something else we need to do from a routing perspective that I may have overlooked, but we'll see what happens. So I ping. Right now, it doesn't work. Okay, not a problem. All devices can, ping each other and www. Okay, so yeah, let me stick in order here before I get all wrapped around the axle as to why that's not working. All right, so VLAN 10 is all set up here on router 1. So what do we do now for VLAN 20? Well, we do the same thing. IP DHCP pool, make sure we get our name right because they're going to ding us if we don't. And then we walk through the exact same setup. So if I was to pull back the things that we just did, I could look at this and say, okay, well, VLAN 20, it's a 240, right, /28. And we're going to come down here and say 20. So that's the network statement that would go there. The DNS server, it's the same. And then I'm going to pull back the default router, which is going to be 20.1. And now that's it. That's the configuration for that pool. If I was to do a question mark, you can see we've got the default router in there. We've got the DNS server in there. We've got the network statement in there. So now I should be able to come down here to PC2 on VLAN 20. Come to the desktop, come to my config, static is chosen as default, flip it over here, and I should get 20.11 because the first 10 IPs have been excluded. And not the terminal, but the command prompt. And let's see, can I ping 172.31.20.1? And we know the answer is going to be yes. If I'm getting the DHCP address, right, unless there was an ACL configured on router 1, we're going to be just fine here. So VLAN 20 works. Now let's knock out VLAN 30. Again, our focus here is on DHCP. IP DHCP pool, and it's going to be VLAN _30. And so pretty simple, right? I'm going to recall the default router, change it to 30.1, which is the sub-interface IP from router 1's router on a stick config. I'm going to put the DNS server in there, and then I'm going to pull back, I think I went right by a network statement. So this is going to be a /128/25. So we're going to say 128. I'm going to roll over here. Whoops. And we're going to change the third octet to match that VLAN. So for VLAN 30, we're good to go. Let's come over here to PC3 and let's confirm that statement. So I pull the IP config up. I go to the DHCP tab and I should be 30.11. I am. And then let's come over here and make sure that we can ping, we can ping 172.31.30 4.1. And we know that that's going to work, but again, doesn't hurt to check things out. Now let's knock out VLAN 40. So, and I can actually just do this, right? Save myself some typing, pull up the DNS server, pull up the default gateway or the default router, which is going to be 40.1, and then all I need is my network statement. And remember, the subnet mask is changing here. It's a /20, what is that? 192.26. So 192, and it's for VLAN 40. And there we go. And so that takes care of VLAN 40. Let's come to PC4. We'll go to the desktop, come to the config, flip it DHCP. We should be 40.11. We are. So DHCP is working like a champ. Let me go ahead and ping 172.31.40.1. And we've got connectivity. Now, I've done everything in order. We're at 100 out of 100. I've done everything in order, and I'm wondering if the scoring engine or the packet tracer activity itself, maybe you can't ping it by, maybe the problem was, oh, and okay, it just took a while. Boy, that took a long time, but it worked. I was wondering, they had us put the DNS server in there, but I was thinking that maybe the reason that's not working is because there's an issue with the DNS, but there isn't. So we can ping from PC1 out to that internet box, and let me ping www.cisco.pka here on VLAN 20. I'm going to kick it off over here. I'm going to do it by IP address on PC3. So let me ping 209.165.201.10. And then it looks like it's still going to take it a little while. Let's go to PC4, and then we'll just go ahead and ping www.cisco.pka. So I'll come back to PC2, and we can see that it's working now, right? We'll come to PC3, and after some ARPing and some timeouts, it's working. PC4, looks like we may be waiting a couple seconds here, but again, there we go. I'm confident that it's going to work. Okay, so most important part of this activity, let's do this. A couple things we want to do here. Right? It's good that we've got the configuration, right? That's great. We've got the 100 out of 100, and that's all fine and dandy. But let's talk real world. So now you want to say show IP DHCP, DHCP. If I do a question mark, you can see we've got pool, and that's going to show me information about all of the pools. I can also say show IP DHCP binding, and take a look at the information I get from the binding. We see the Cisco formatted MAC address here, where it's the 4 hexadecimal characters, a period, 4 hexadecimal, then a period, then 4 hexadecimal for a total of 12, and 12 hexadecimal characters, which are each 4 bytes, are going to be 40, I'm sorry, each 4 bits. Each hexadecimal character is 4 bits. It's going to be 48, and I'm saying that wrong. Each hexadecimal character is 4 bits. It's 48 bits total in the MAC address. I apologize. I got confusing myself there. So, but we say show IP DHCP binding, and we see the MAC addresses. We see the lease expiration, right? And we see the IP address that's been given out, and it was automatically assigned. So that's how we can see some of the information. Now, I can also say show IP, and let's see if it's here. Show IP DHCP. And if we had a relay, I could say relay and get the relay information. Whoops, get the relay information from trusted sources. However, we don't have any relay information going on, right? Because it's all in the same broadcast domain where DHCP is being handed out. All right, so that is some additional information. And again, remember, if I was to say show run, we've got our excluded statements, and there are the DHCP pool configurations for each of those subinterfaces. All right, well, that is going to wrap up Packet Tracer Activity 8.3.1.2, where we took a look at DHCP. We did some easy VLAN configuration. We did some port assignments, did some access port configuration, some trunk port configuration, but most importantly, we focused on DHCP. All right, guys, thanks so much for watching. Good luck on this activity, and I'll talk with you soon.